Dear students, today we will see how to do the online laboratory. So first we will go to the canvas. So your interface will be looking like this. This will be the dashboard. Many of you may not have the same dashboard. If you don't have the same dashboard, you can search in the course list also. But here in my interface, I can see the virtual laboratory. So I will be clicking the virtual laboratory. Now you please go to page button. So pages. Here you can see the 12th experiment. So click it. Depending upon your internet speed, it will be loaded. Click on the image. So you will be directing into an interface looking like this, and this is powered by a CDAC. It is one prestigious organization in Kerala, and it's a collaboration with Amrita University. And here you can see the lot of experiments in physics, especially which belongs to class 12, potentiometer, figure of merit of galvanometer, conversion of galvanometer, and a lot of experiment. And all these experiments are designed according to the latest CBSE syllabus also. So first we will do this experiment, Ohm's Law experiment. And many of you have done the Ohm's Law experiment in class 10. So there we have done only the resistance of the particular wire. But here we will do the resistance and specific resistance. That means the resistivity. Resistance per unit length over a cross section is called the resistivity. So in order to do that, just click on the Ohm's Law resistance and theory part. And here in the theory, what are the equipments you needed and what is basically the Ohm's Law, everything is shown. And after that you may click this button. Here you can see the procedure, how to do the experiment. So these are all the descriptive level of the experiment. For every experiment you will see this kind of interface. So here in procedure, what are the things you need to do and what is the formula you have to do it. Rho is equal to pi r square, r divided by L. Pi r square is the area of the wire, means a cross-sectional area, and capital letter R is the resistance, and L is the length of the wire. So these are the procedure. Now we will omit all these least count and zero error everything, because our experiment already set in a standardized value. So here also you can see the ammeter reading and voltmeter reading, corrected value, everything we can replace as simply ammeter reading in ampere and voltmeter reading in volt, and the resistance in the last column V divided by I is equal to R. Also we will find, and make sure that we will mention or we will find the length of the wire before doing the experiment. That has to be noted first. Again we will go back to the menu. So procedure, theory, procedure we have done. Now animation, that is not necessary. If you want to see the animation, that also you can see. And simulator. So before going to the simulator, here in simulator only we will do the experiment. We will go to video, how to do this experiment. This is very much important because it is a real case of an experiment, how to do this experiment. So if you watch this video, it will be much easier to do the experiment in real laboratory. Here we are not going to do the experiment in a real laboratory. We will do in a simulation, and all values you have to note it. Means a voltmeter reading, ammeter reading, resistance, nature of wire, and diameter of the wire, everything you have to notice. We will again go back to the menu. Now the real game is here. We will do the simulation. So we have seen theory, procedure, animation not needed, and video and simulator. So here simulator, you have to do the real experiment at your home. So what is this interface looking like this? The interface will be looking like this. So depending upon your laptop screen or mobile screen, the thing is looking like this. And now what you have to do here, you can see that it is a wire. You can select any wire, copper, gold, aluminum, iron. So first we will do the experiment with nichrome, because in our lab we have a nichrome wire, and the length of the wire you can change into 10 centimeter, 40 centimeter, any wire you can change. So in the beginning of the experiment, you change the wire length of the wire into any desired value, and the diameter of the wire is 0.2 millimeter. That will be more better, because resistance of the nichrome wire is much more compared with any other wires. Now resistance of the rheostat, here also you can see rheostat is that, you know, it is a variable resistance. By adjusting the rheostat, you can change the value of the resistance. You can see this rheostat can be adjusted. Now rheostat I am adjusting, and the rheostat is nothing but it is a resistance, variable resistance. I have set the rheostat value into 40 ohm here. Now if you want to see the show result, you click the show result, or if you want to change all these values, means nichrome wire, length of the wire, diameter of the wire, resistance, everything, you can click this reset button. Now I am not resetting. And if you want to see the circuit diagram, you just click here the circuit diagram. It is also clearly it is written circuit diagram. So, I told you, you must watch the video in the video section how to do the experiment. Then you need not to click in the show circuit button. So what is the circuit? If you are not aware, the circuit is simply a battery. Battery negative is connected to the key, then towards the rheostat. RH is the rheostat. Rheostat is a variable resistor, and from the top portion of the rheostat, you can see the arrow mark. From the top portion of the rheostat, the wire is going to the voltmeter negative and a resistant capital letter R. This is the basic resistor which we have used as a nichrome wire. So nichrome wire is always connected in parallel with the voltmeter. In class 10th you might be studied resistors will be always connected in voltmeter, or vice versa. Voltmeter will be connected always across a circuit, means parallel with the circuit, any electronic component. But in the case of a ammeter, you can see ammeter is connected in series. Why do we connect voltmeter in parallel and ammeter in series? It's very simple. Voltmeter has a very high resistance. So if you connect voltmeter in series like ammeter, it will consume a part of the battery power. So we will not connect voltmeter in series. And more than that, voltmeter is a device to measure the potential difference. So in order to measure the potential difference, we need to connect the voltmeter always at two different points. So we will connect voltmeter across the resistor.